Okay, so linear functions and graphing them, or linear equations and graphing them. So when you're solving a linear equation, remember a linear equation and a linear function is just a relationship, right? And this goes for any equation, any function, anytime, no matter what, right? Even with a student that I'm working with in pre-calc right now, and we're graphing rational functions, and it's like 1 over x squared minus 2x plus 3. And we just go, you know what? We can just start plugging in values, right? It's always just a relationship, right? You know, if it's 2 to the x power, like you just start plugging in values and you'll get a good idea of what the graph is going to look like. And that's like one of the first things that you learn about graphing, right? And about graphing a line is that it's just a relationship between the two things, between the two variables. Hi, I'm Sarah. I've been a STEM and science and math teacher for over 20 years, and I like to make math and science engaging and fun and not so scary for everyone involved. If you like this, if you want more math content, if you need tutoring, micro tutoring, check out my Cameo. If you have a math question, you have something to add to the Math Thursday list, send me a comment. When we have a linear equation, like if we had something like y minus 3 equals 4x plus 4x minus 1. Okay, so we have something like this. So what you want to look at is you want to look at the relationship between the y and the x. Now I can graph this as it is right now, but usually it makes it a little bit easier if you can get this into a form that's a little more recognizable and a little bit easier to graph, which is the slope-intercept form. So the slope-intercept form is y equals mx plus b. This is the one that everybody usually just can rattle off. This is one you don't forget. Y equals mx plus b. M is the slope. So that's going to be like the angle that it's changing. And it's really just like the change in the rise over the run. So if you think about it, it's a ramp on top of some stairs, right? It's the same idea, right? So the ramp is smoothing it out, but ultimately you're going up and forward and up and forward. Or maybe you're going down and forward and down and forward, right? So depending on the slope, and it changes, like if you have some really steep stairs, that means you're like barely going forward and you're going way down, barely forward, way down, right? Or if they're really long stairs, right? You have those like those long stairs and then you go burp down, then you go long stairs and then boop down, right? So the slope depends on how much you're changing vertical and horizontal, right? So thinking about a 3D printer. 3D printers just move back and forth and side to side, slightly up, right? But back and forth and side to side. But they're able to do all of those different shapes because it's just a relationship between that horizontal and vertical movement, okay? So that's what the slope really is talking about. The B always stands for y-intercept. That's where it intersects the y-axis. So we have the x-axis. This is all the x values, right? The x values, and then the y values are here. And this x and this y, these make up the points, okay? So x and y, those are going to be the points. So what we want to do is to get this into slope-intercept form, I just need to get y alone and on one side. So the way I'm going to do that is we're solving these equations. So y is here, but it's y minus 3. So just need to get rid of that 3, and I can't just take that 3 off and just not do anything else. But what I can do is to cancel this out, right, to make it so it equals 0. If I just add 3 to this side, right, I have negative 3 and I have positive 3, and those are going to cancel out. Those make those 0 pairs, right? So now I've got y by itself on this side. I can't just add 3 to this side and then move on. I've got to add 3 on this side also, right? I want to keep it in balance because otherwise I can't, it's not going to be equal to the same thing, right? Y minus 3 is 4x minus 1. So I can't just add 3 because then it wouldn't be the same thing, right? So I'm going to add 3 to both sides to keep it balanced. So you always want to try to get the y by itself in this case, right? So you always want to get the y by itself. So whatever you need to do to get that y by itself, and then x just kind of goes along for the ride, right? Everything over here just kind of ends up being whatever it is, and then we graph it, right? So y equals 4x. I haven't done anything to the 4x, right? Because those are not like terms. I can't add that 3 to 4x, but I can add the 3 to the negative 1, right? And that gives me positive 2. Okay. So if y minus 3 equals 4x minus 1, then also y equals 4x plus 2. Okay. All right. So now that I have that, I've got my information. So I know that my slope is 4. Right? And again, my slope is like, what are my steps with the stairs, right? Or with the ramp, right? So my slope is my rise over my run. Think about stairs, right? You're going up, forward, or you're going down, forward, right? So rise over run. So that means that every time I move up 4, I move forward 1. It's 4 over 1. Rise over run is 4 over 1. And then our y-intercept is positive 2. So that means that my line, which is y equals 4x plus 2, that means that it's going to cross the y-intercept at positive 2. I'm going to go ahead and mark that. Might as well. So positive 2 right here. Okay. And then I think about my stairs, right? I'm going, remember, to my next point, I'm going to go up 4 and over 1. So that would be up 4. Ooh, I ran out of room. But I could go backwards, right? I could go back down the stairs, right? So I'm going to go down 4 and back 1, right? And I don't have room to do another point, but all I really need is 2 points because now I can graph this line. Okay. So even though those are my 2 points that I marked, I know that this line is going to pass through all of those little intermediate little tiny points also. Okay. So we brought down the 4x, yep, because the 4x, nothing happened to the 4x, right? So now we ended up with just the 4x plus 2. Okay, and so this graph is the line 4x plus 2 because we go up 4 and over 1. And then we would keep doing that, right? We go up 4 over 1, up 4 over 1. It's just going to keep going at that same line, that same angle the whole way. Okay. What is y in the equation? Y is the y value that's going to be on the y-axis here. X is the x value that's going to be here. So when x is -1, y is -2. Because 4 times -1 is -4, plus 2 is -2. It's mathed up.